This will be the only video you ever need to watch on machine learning and meta ads. We'll be diving into targeting, bidding, creative optimization, everything that you need to know and understand so that you can set your meta ads up for success. So many people are spending hundreds of thousands of dollars a month on the meta ad platform, but they don't even understand how the meta ad platform even works and is even deciding how to serve their ads. You need to understand the core frameworks of how Meta is even working as a platform so that you can start to build decisions and SOPs and account structures off the back of that. So to give you a quick view into what we're going to be talking about, there's a lot. I'm going to start at the data pipeline and labeling. We're going to go into audience targeting. We're going to talk about bidding and auction optimization in real time. We're going to talk about how Meta does conversion predicting. We're going to talk about creative optimization, budget allocation and reinforcement learning. And then lastly, we'll finish it all off by the big question, which is that you have the account data, you have the campaign data, you have ad set data, and you have ad data. What's actually being used when you go and serve an ad in front of a user? How much of that is getting pulled into the decision making? Is the account imported? Can we ditch the account, start a new one, bring the pixel over, and we'll bring all the data? I'll answer all of that, but we need to start at the very top. We need to start at the basics. And this is going to be a video where I draw. So I apologize in advance for this terrible drawing. So what we end up starting with is we have data on each user. And this data is inclusive of likes, shares, comments, anything to do with the platform. But Meta's also trying to pull as much data as they can from outside of the platform. So if you have any third-party integrations linked with your Meta account, and I mean, if you've logged into a website, and you know how you can log in and you can click sign in with Google, or you can click sign in with Facebook. If you've ever done that, the reason why Meta allows you to do that is so that they can scrape that data and use it in their ad targeting as well. And so any possible data that Meta has on you, any interaction you've made in the platform, they want to use that in their targeting. But the data itself is raw and useless. And so they clicked on this post, they clicked on this post. It's just a bunch of numbers, but it doesn't mean anything. And so we need to go and actually label that data. And so this is what Meta does incredibly well. And this is where the introduction of machine learning over the last few years has allowed a lot of advances in the structural approach to ad targeting, to my understanding, which is that previously this was done relatively rudimentary in the early days of Meta and the early days of digital advertising, which is that if someone clicks a like on a page and that page is classified as a pets page, then we will go and label this person as someone who likes pets. And so if you were then going and targeting the pet interest, or Facebook identifies that you're selling pet products, you'll target this person. This is obviously a large simplification of one single data set, but you get the point. Now, where this has become more complex over the course of the last few years is in vector embedding. And so rather than actually putting a name to this, we could just associate a number. And that allows us to create much more complex interactions on the platform. So rather than just labeling that this person, for example, liked a pet post, let's take a bunch of interactions that they had. Let's not just take one. Let's take all the likes that they had today. And let's associate some kind of unique number to those interactions. And then from there, we can embed that into a high-dimensional vector space, which then places that individual user somewhere in space, which we then start optimizing towards. If you've never watched or learned about machine learning, that's going to sound like a lot of gibberish. I'll try to do my best to explain it in layman's terms, which is that you can, and we can just look at a three-dimensional space here. So this is our y-axis, this is our x-axis, and this is our z-axis. So this is going backwards. And this technically isn't how you should draw this, but whatever. From here, what we want to do is we can say that if you liked a pet post, we're going to go and push you 1, 1, 1. And so you are then, rather than going to be positioned at 0, we're going to push you 1 up the z-axis, 1 up the y-axis, and 1 up the x-axis. So you might sit here now. And then if you then go and click on another pet post, we're going to push you again 1, 1, 1. And so you're going to move from here, and then you're going to move again over to here. And then if you then go and like something completely different, maybe cooking has a vector space orientated with it, which is 1, 0, 4. And so we're then going to push you over, and I'm not going to figure this out, but I'm just going to make it arbitrary. We're going to then go and push you over in this direction. And so what's then happening for each individual user on the platform is they're getting pushed around this vector space based on their interactions within the platform so that we can start to cluster users. And so you'll notice this if you have a friend who has just all the same Instagram reels as you, or they have all the same algorithm, it's because they're interacting with things in the same way that you are. And so you're actually getting clustered together inside of this vector space. Now, where this gets really hard to conceptualize is that these vector spaces aren't three-dimensional. And so there isn't an X, Y, and Z axes. There's often hundreds, if not thousands of axes. And so rather than someone getting pushed, let's say 1, 1, 1, 1, if they interact with a pet post, they might be getting pushed 1, 0, 0. Imagine I'd go and write 100 more zeros, right? Because there's hundreds of dimensions here. And then it's a 1, and then it's 100 more zeros, and then there's a 4 here. And so we start to get very specific in the way that we can cluster people across a lot of different dimensions and a lot of different interactions. And so this is where we can start to introduce enormous high volumes of data and start to really precisely map people into a space with similar users. And so then when we go in and we say, and this is why interest targeting is dying, by the way, there's going to be a lot of little nice nuances in this video that I'll reference out into how targeting is working so that you can get an understanding of how this matches. But that's one of them, which is why broad targeting is better than interest targeting these days. One of the reasons for that is because back in the day, it was very simple. If someone liked pet pages, they were labeled as a pet person, and you would just go and target the pet interest. But now they're not labeled like this. Like, yes, Meta knows that this user sitting over here probably has an interest in pets, but it's just sitting in a high dimensional vector space. And if you just go broad, Meta's just going to go and find out where on that 100 dimensions, where in the area does it need to go and target. And it's just going to target that cluster of people, regardless of whether they like pets or not. Because what you'll end up finding is that someone liking pets often isn't a incredibly high intent signal in itself. It's often people liking pets that interact with these kinds of posts that also seem to have 2 kids, that also live in this area, that also do this. And so that's a very specific 10 different character traits or psychographic data points that have all been centralized into one specific space where maybe 20,000 people sit there. And you're only going to go and be able to actually hit those users if you go broad. If you go with interest targeting, you're just going to blindly target anyone that has that interest, which isn't going to be as effective. And so that's why broad targeting has gotten quite popular. And that's why obviously Meta is rolling to that kind of targeting exclusively. So that's the data pipeline and engineering and features. And so there's a bunch of raw data. We need to then go and label that data and actually apply features. It used to be done like relatively manually is how you can think about it. Now people are positioned within a large space and then clustered together. So the next point here is audience targeting. And we have kind of addressed it here, which is that Meta's going to use clustering of users and cluster all these users together. And then they're going to embed users into this space. And so a really nice way to look at this is something like this. Right? And so each of these individual dots is an actual user. And then you can see how these users are all sitting in different positions, but they're kind of clustered together. And the reason for that, and obviously in this case, they've gone and colored it so you can very clearly see the distinctions. These different colors represent different psychographic data point similarities between these users. And so this over here in the orange might be mums between 30 to 40 that have a collective similar interest in particular things. And then red are different people. Now, the reason why red is spread out is because these people don't have identical interests. They're all different. They all have slightly different interests, but generally speaking, they sit in the same position. And so they're probably going to be a group as an entirety that's going to resonate with your ads if you resonate with a few of these people. And then obviously you can see that color graded elsewhere. So this is how you can think about targeting. So we've gone through the data pipeline and labeling. We've gone through audience targeting. What about bidding and auction optimization? So when you go and serve an ad, you go into an auction. There is a bunch of different advertisers that want to serve an ad to an individual user on the platform at that individual point in time, but only some person wins. Okay, what makes you win an auction? And how is machine learning involved in that actual process? So here's an ad being served to someone. There is 2 different methods, statistical methods that Meta uses. At least a lot of this is kept private. They don't make a lot of it public, but from what people can tell, there's 2 things that they do. They either use a logistic, and I'm giving you these so that if you want to learn more about them, you can go and search them up and watch videos on them. Number one is they use logistic regression, or number two, they will use tree branches. And so I'll just rename that to tree-based models. And so both of these are just regression models using all of the data that we've just talked about to be able to create a prediction on the likelihood of serving that ad leading to the outcome that you're optimizing for. So if you're watching this channel, I hope most people are optimizing for purchases. Well, you might be optimizing for leads. And so because of that, what we're doing here is we're going, what is the likelihood of this individual user going to be of them actually making a purchase once we serve this impression? Now, it can get a little bit more complex than this, and obviously Meta's always tweaking their algorithm to improve it to maximize for revenue. And so they might actually be doing an optimization function here to go, what is the likelihood of click and therefore purchase? Because an impression in itself sits very far away from purchase. But I think they've ended up finding that the more you can just optimize for the final event, the better the optimization ends up being. And so there's really two core KPIs that are going to lead to purchase if this is what you're optimizing for, which is, and hopefully you know this, it is CTR. They have to click on the ad to actually buy. And what else do they have to do? They have to convert. And so this is really an optimization function for what is the likelihood of click and then what is the likelihood of conversion. And so when we're looking at this individual user, we're going to see where they sit within that vector data, within that vector space, and go, when someone sits in this area, what is their average click-through rate on one of our ads? And what is their average expected conversion rate? Is essentially what's happening. Now, this is just statistical methods to be able to do that at scale very quickly. But that's essentially the analysis that you're doing. And then you're going, well, they actually have quite a high likelihood of CTR. They might not have a very high likelihood of conversion rate, but once we multiply these two numbers together, we find out that the CPA expected is actually $30, which is on target. We're happy with that. And therefore, we're going to bid at a level that gives this expected outcome. And so we can't go and bid too high, because if we spend too much on this user, the cost goes up, the CPMs go up, and then we won't actually get a $30 CPA. And so the bid ends up being set at the optimal level to where if we do win the auction and we serve, we will get our CPA target. This is where cost caps come in. And so cost caps end up working really effectively because you're fixing this dynamic within the auction. And you're saying, hey, you cannot go and bid as much as you want on this user. You need to go and restrict it. Okay, even if you think, yeah, a purchase is going to occur here, if there are competitors coming in and bidding enormous amounts for this user, and you don't see the bid that we would have to serve being profitable at our CPA constraints, don't do it. And that's where cost caps end up driving a lot of efficiency into accounts. And that kind of structure, in my opinion, is really desirable if you can get it to work and you have the creative velocity to support it, which most people don't. And so that's why I think blindly just saying run cost caps isn't the most constructive piece of feedback for majority of 7, 8, 9-figure brands. Maybe 9 figures, it's different because you have the ability to rank creative production. But most people just aren't doing enough creative to even sustain cost caps at the spend levels that they want. And so they're kind of better off just bleeding in efficiencies in overbidding on particular users than constraining their spend and constraining volume. And so that's how cost caps ties into this. And so just going through the journey now, we've gathered our data on users, we've labeled it, we've then gone and done audience targeting. So maybe we're just serving this ad broad. The ad's been served, the user's seen it. We've decided that the algorithm has decided that this is a user that we should actually bid high on, and we've won the auction against our competitors. Fantastic. Now what? So what's the step after this? Well, the user hits the landing page, and then we have to introduce a new level of machine learning, which is conversion prediction modeling. And so the user's going to go onto the website and they're going to interact in a bunch of ways that are going to be hopefully attributed using a pixel. We then take all of this data and we feed it back into the platform to do two things. And this is what ends up being really interesting about how machine learning works within the platform. And this is the learning phase that you'll sometimes hear referenced by a lot of people. Because what's happening here is this data gets used to reinforce the targeting within the ad as well as the auction. And so, for example, if this user ends up clicking and we have a high prediction that they're going to convert and they don't convert, that gets pushed back into particularly the tree-based models down here to then reinforce away from this type of user. Now, we don't want to reinforce completely away from very simple labels. For example, if this person's interested in pets and we're selling pet products, we don't then want to reinforce back and say no longer target anyone that is interested in pet products. And that's why there's so much complexity in the labeling process here. And that's why it uses vector-based positioning so that we can just reinforce away from one particular attribute that this person might have that's not desirable. And so as we start serving and we get more and more clicks to the website and we're feeding this data back into the platform, we're getting reinforcement learning that's allowing us to target more desirable people that have a higher percentage action rate, which is really critical. Now, this isn't just reinforcing based on the percentage action rate. So if it's purchase, if it's fill out a lead magnet, whatever it might be, that isn't the only thing that's being optimized for here. There's a wildly complex amount of data that's being pulled back in. Okay, so it's time on website, customer journey across different pages. There's add to cart interactions, other different pixel events that could be firing. All of these things are firing, getting pushed back, and are being used to weight the decision-making of future bits. It is also worth noting that meta attributes based on a last click attribution model. So when you look in the platform, you'll see a purchase from an ad or an ad set or a campaign, and it will be from the last interaction that the user had with that particular ad, despite them potentially clicking on multiple different ads. But the machine learning algorithm does not exclusively use last day click. So the machine learning algorithm is using multiple different interactions with multiple different ads, which is where people sometimes make a mistake where they'll come into an ad set and they'll look at the ads within this ad set, and you might have ad 1 here, you then have ad 2, and you have ad 3, and you find that one ad has a really strong return on ad spend and is getting, let's say, 40% of the spend. You then have another ad that has a considerably weaker return on ad spend that's getting more of the spend, and then you generally have one ad over here that might be on some random return that is getting no spend at all, so maybe 15%. And then the obvious change to make here is to come in and go and turn this ad off, because we want to distribute spend into the high performing ad. But it is always worth noting that all of this machine learning is going on in the background that you aren't privy to. And so the question always is why? Why is Meta going and putting all the spend here? Are they trying to just rip you off and spend your money on an ad that's not performing well? No. They're distributing spend here, likely because they see something that you don't. Maybe expected conversion rates on this ad is actually higher than the top one, and so it believes that once you get to higher budgeting, this will actually end up outperforming. Maybe it's not looking at last click attribution, and it's actually saying that people are viewing through this ad, and then they end up clicking on this ad, which ends up leading to the conversion. And so it's a very dangerous exercise to go in and impose your own human bias at an ad level and start making changes, which almost everyone does. Like every audit I see, people are going in at the ad level and then just making manual changes, turning ads off, turning ads on, despite them having no insight into all of the machine learning that's going on in the background that's predictively distributing spend. And this leads us really nicely into the next 2 points, which is creative optimization and then budget allocation and reinforcement learning. And so when you go and structure an ad set, and so let's call this an ad set with 3 different ads that sit within it. And this could also be a CBO, so we can think about this top level being a campaign or an ad set. It doesn't matter. You then have budget that's getting distributed between these. And let's say this is set at $1,000 per day. Cool. So the question is, how does it decide to distribute budget here? Well, we kind of just went through that in terms of the fact that it's going to use predictive modeling on conversion rates. And once again, this is expected conversion rates, and it is expected click-through rates of each of these ads. But the thing that Facebook also does really nicely is it doesn't look at ads in isolation. And so it's not doing these calculations individually for each ad and then leaving it there. And the reason why they're not doing that is because, and you can check this in your account right now, frequency of an individual ad will very rarely, now it will in some accounts, and some people are going to open up and see that this rule doesn't apply to them, but it applies 90% of the time. Frequency of an ad pretty much always is less than 2. Let's put a buffer and say 2.2, which means that an individual ad is almost never served to a user more than twice. But go and look at your account level frequency. And so just zoom out to your account and have a look at what the frequency number is across it. Probably, if you're a big brand in Australia spending 150K, 200K a month, this is probably going to sit at something like 3.8 if you're looking at a 30-day period, sometimes even higher. And so users are getting served 3, 4, 5 ads on average, and high-intent users are going to be served 7, 8, 9 ads. But they're only seeing an individual ad twice. What's the reason for that? The reason for that is because probability of purchase after 2 impressions of seeing the same ad goes down exponentially. And so when you look at probability of purchase on the y-axis and then ad volume, frequency actually, it looks like this. And so serving an ad to a user more than 2 times is a futile effort. But what you can then end up doing is if you can introduce a new ad at this point, so serve user a second unique differentiated ad, this probability curve holds up. And then if you go and introduce a third ad, you can hold it up even for longer. And so differentiation in creatives that are being served to the user is what ends up increasing probability of purchase across multiple different impressions. This is really, really important to understand because number one, it means you should go and launch way more creatives than you currently have in your account. But number two, it ties into the way that the machine learning is working at the individual ad level and the fact that you have to trust the way that Meta is distributing spend. Because if Meta is distributing spend to a particular ad and doesn't have a high attributed ROAS, it is doing something within that ad set to achieve the expected outcome at the ad set level, right? If you have a cost cap here and it's still going and distributing spend here, there's a reason. And it's because it's playing a part in a customer journey or it's playing a part in this mix to be able to drive the expected outcome. This is obviously also happening at the campaign level. And so if you have a CBO up here, let's say this is spending 500 per day. This is one of your ad sets. You might have a second ad set as well. It's constantly looking at the variables across these 2 ad sets. It's looking at core KPIs, in which there's quite a lot. We're simplifying down to expected conversion rate and click-through rate. But the issue is that there are preliminary metrics on both of these that you need to use to also substantiate the expected outcome. And so when you're looking at expected click-through rate, yes, you can just look at a vector database and say this person sits here and their expected click-through rate is this. But you ideally also want to factor in the ad historically. Does this ad get better click-through rates? Yeah, it does, than anything we've ever had before. Okay, well then the expected click-through rate of this user is probably actually higher than the predictive point in the vector database. And then, we also want to factor in that this ad set has exclusions on it, and so we're actually not able to target any of these high intent people, and so that's going to drop CTRs as well. So there's other factors that need to be weighted in, and all of these are constantly being rebalanced at the CBO or the budget level to be able to determine how budgeting at a minute-by-minute basis needs to continually change between ad sets or between ads. And this component of the machine learning within the algorithm is heavily reliant on reinforcement learning. And so essentially what's happening here and how reinforcement learning would work is it's going to go, all right, we're going to allocate more spend to this ad set because we believe it has better CTRs and it has better conversion rates. And therefore we're going to get a better expected outcome, which we're optimizing for, which is purchases. And then it does that and it doesn't work. CTRs go down, purchases go down, CPAs go up, and that reinforces back into the model and tells the model, don't do that again. Instead, redistribute budget here. And then it moves the budget backwards. And it's doing this in real time, constantly refreshing as new data comes into the model. To make this even a little bit more complex is that it's not as simple as that because they're not optimizing strictly across short-term performance. If it was, it would create a massive imbalance and you'd just see budgets flying around between these consistently, right? You'd see a slight bit of bad performance here, and it would just throw the budget into the other ad set, and then it would just throw it back into the other ad set. And so it's also using long-term goal orientation as well to be able to balance the short-term changes. And so it's looking long-term and then adjusting the aggressiveness of the reinforced changes in real time to be able to deliver a daily or a weekly result. Now, this is a really interesting insight, zooming out, which is why recently did Meta put the ban on health products? Okay, you can no longer optimize for good signals like purchases if you're selling health goods. And the reason for that is because back in the day when it was just interest-based targeting, once upon a time you were able to target pretty much anything you wanted. But a year to 2 years ago, they removed all the sensitive interests. And so if you wanted to go after a sensitive category, let's say it's people with diabetes, and you want to go to them with a product that is a bit exploitative of the fact that they have diabetes. That's obviously not in line with regulations. And so Meta doesn't allow you to target them. But now that that isn't explicitly labeled, but instead it just sits within a vector database, you can effectively just target people with diabetes. You just have to make your copy and your messaging resonate with that particular audience, and you'll go straight to that position in space and just target all those users. And so you can very much so just exploit any audience you want if you have messaging that's hyper-specific enough to that audience, and you'll directly target those people, even though you're not specifically mentioning it. And so because of that, Meta obviously is in a little bit of strife. And so what they've had to do is look at websites and ad copy and go, if you're using terminology that we're going to pick up in our algorithm and use to reinforce on targeting that is exploitative, we're going to stop you from being able to actually optimize for purchases and gain all the benefits of a lot of the machine learning. Now, you still get the benefits of quite a bit, but it makes it a little bit more vague. Your targeting's not as good. It's not as precise. And they do that based on the copy and the creative, the transcript, and the landing page, because those are heavily used in Meta's ability to go and target these people. And so that's an interesting tie-in here, where there's almost ethical considerations in the fact that you can get so much more hyper-targeted now just by having the right copy, the right hooks, the right transcripts, which is obviously the voice within the ad, as well as the right landing pages. And so let's now go to the very last question here. So we've gone through bidding and auction optimization. We went through conversion prediction modeling. We went through creative optimization. We went through budget allocation and reinforcement learning. And now we have the last real golden question, which is, and there should be an additional account up the front here. So you've got the account level, you got the campaign level, you got the ad set level, you got the ad level. What is the involvement in the bid? So here's the account. We then have our campaigns that sit under the account. We have our ad sets, we have our ad, and then ultimately we have our users down the bottom here who get served the ad. So when this ad gets served to this individual user and the bid is being made, all of the machine learning is being put in place to be able to decide what that bid is and who the person even is that we're going to go and target. What is the involvement from all of these different levels of account data? At the account, let's actually start at the bottom. So at the individual ad level, what's going to be considered is recent creative performance against this individual user. I think it's time to retire the pen and just pull text out, which is recent creative performance. So there's a bunch of different creatives that are actively running within this particular campaign or this ad set. There's going to be determination of all of our ads, which individual ad resonates best with a user that has these types of psychographic data points that this user has. That's the main one. Once we move up to the ad set level, this is where targeting is going to become more important. So even though targeting these days doesn't really exist, right? On an Advantage Plus campaign, you don't even have an ad set level because there's no targeting. On broad targeting, there's really nothing to find at the ad set level. It just kind of sits there and maybe you'll set budgets and that's about it. But the targeting optimization-wise still does sit at the ad set level. And so the determination of who we are going to be going after, the kinds of users that we're going to be targeting on the platform, that optimization is sitting here. And so when you go and make a massive budget change, for example, it's going to impact and change who we're going to be targeting. It's not going to be changing recent creative performance and the determination of which creative to serve to those individual users. So these decisions are being made separately. Then up at the campaign level, we have historical trends and budgeting. So if you have your budget at the campaign level, like a Advantage Plus campaign or a CBO, it's going to be doing decisions on how it should be distributing budgets. And it's going to be inclusive of historical trends, and it will be pulling out insights from adjacent ad sets to be indicative of the targeting at the ad level. And so it might be the case that a separate ad set that's also on broad is finding success in a particular population group or group of people, and it's going to go and translate that and actually embed that into the targeting of a different ad set. And then we go all the way up to the account level. And this is where agencies owning your account is incredibly dangerous, because the data sits in the account. It doesn't sit in the pixel, which is obviously the dangerous part. And this is where you get cross-campaign insights that are factored in, as well as account-wide historical data. And so you're getting those historical trends, but you're getting them across every campaign that's ran historically within the account. And then you're getting cross-campaign insights. And now I've seen this mentioned multiple times by Meta. And so this is not something to be just passed on and video ended, which is that Meta very often apparently will look at other similar campaigns with similar creatives and actually pull data out of them to use them in new campaigns and new ad sets to ensure that they learn quickly. This is effectively what Advantage Plus campaigns do. If you don't know how Advantage Plus campaigns differ from ABOs and CBOs, Advantage Plus campaigns skip the learning phase by using all historical account data to create instantaneous lookalike audiences and go after people that it believes will be warm out of the gates, rather than going through this learning process, right? You've never seen an Advantage Plus campaign in the learning phase because it doesn't exist. It skips the learning phase and it just goes against lookalike audiences. And there isn't as much reinforcement of data in that campaign type compared to an ABO and a CBO. And this is really just one big move. And you can start to understand why Meta's making these changes and doing these things once you understand how all the machine learning works, right? This is just one big move towards Advantage Plus, because vector-based labeling of users is much more effective than going after a sample size of new users and then reinforce learning off those users, which is how these things used to exist. And so when you launch an ABO, it's going to go after a sample size of 1, 2, 3, 4,000 people. It's going to gather those impressions. And then based on the way that those users interact with the ad, like comment, click, purchase, it will reinforce into the psychographic data points of the users that are in line with the action rate that we want. And so that's why you need 50 purchases to get out of a learning phase, because Meta wants to gather 50 points of data before it starts specifying down and hyper-targeting into a specific audience. Now, Advantage Plus just skips that, and I'm pretty much of the belief these days that ABOs and CBOs are kind of skipping that as well. And they're doing a lot less of this very broad, cold targeting, go after anyone, and then reinforce on the data. And they're just right out of the gates going after people that are high intent anyway. It's using the account level data to get to the right people quite quickly. And so that's hopefully everything that you need to know about machine learning in Meta ads.